All right, so now that we know the parts very well, let's go ahead and let's get to know the 7 theorems, okay? Yes, let's go through them as fast as we can. So, the first one is one that says that the angle in a semicircle is a right angle. The angle in a semicircle is a right angle. Okay, so the moment we hear the word semicircle, we know there has to be a diameter there. So, what it's simply saying is if I have a diameter like this and it makes an angle somewhere, wherever it is, then that angle it has made is a right angle. So the angle made by the diameter is a right angle. Please make sure you've put that somewhere safe. This is a right angle. It's going to be 90 degrees. That's what it simply means. Okay? So great. Now we'll go to the second one. It says the angle between a tangent and the radius drawn to the point of contact is a right angle. All right, so let's deal with this. It says point number one, we have point of contact and we have tangent. So we know that a tangent is a line that just touches your curve. Okay, we can put it up or down, we don't care. Let me put it up because there's more space up there. So I'm going to put a better tangent like this. Here is our tangent. All right, so now, my bad. Let me just draw it straight like that. Okay, it's not going to be the best, but it's just for your understanding. So there we go. Here is our tangent. My gosh. All right, great. Here is our tangent. And here is the point of contact right here, where the tangent meets the circle. Now, they say the angle between the tangent and the radius. So a radius is a line that's going to come from your center to the tangent, to the point, to the circumference, sorry. And this radius is going straight to the point of contact. That's what they've said. So we have our radius, this line that comes from the center and goes to the circumference, and it's going right to the point of contact, which is where the tangent meets the circumference. They said now the angle between the radius, this is your radius, okay, and the tangent, here is your tangent, at the point of contact, which is right here. There is the point of contact. This angle is a right angle again. So this is a right angle. So that means it's 90 degrees, like which we've just shown, between tangent and radius at the point of contact, okay? At the point of contact. That angle is a 90-degree angle. Great. Now we go to number 3. Angle at the center is twice the angle at the circumference if they are subtended by the same arc. Now we know what arc means. It's the outside, and it is made when you have 2 radii. So that means if I have something like this, okay, there is an angle like that. And then if I go and put another angle at the circumference like this, okay, here is the angle at the circumference. If I say this is point A, this is point B, okay, let's analyze these 2 angles. Okay, we'll start with this angle, we'll call it X. Then this one inside, we'll call it Y. If we follow angle X is at the circumference, right? Yes, true. And what is it made by? Who is it made by? It is made by arc AB. Here is one leg going to A, the other one going to B. So if one leg is going to A, one leg going to B, that means it is made by arc AB. Great. Now, what about this angle Y? Who is it made by? One leg goes to A, the other one goes to B again. So it is also made by arc AB. Remember that arc is this outside, this thing on the outside. That's your arc, right? Here's your arc. So this is arc AB. Now, basically, we've seen that angle X and angle Y are both made by the arc AB. And if you look at angle X, it is at the circumference. Angle Y, it is at the center. So now this angle at the center is 2 times the one at the circumference. So you can say Y is equal to 2X, okay? 2 times the angle at the circumference, and that is X. So that is what this rule says. Now, here the next rule, number 4, says angle subtended by an arc at this angles subtended by an arc at the circumference that are in the same segment are equal. Okay, so now we have An angle coming like this, going to the circumference, and another one at the circumference again, like that. Great. So we have this angle x, we have this angle y, right? Great. Now we have our arc. This is point A, this is point B. So we can say this is arc AB, the one in green. Now, if we follow angle X, who is it made by? One leg is at A, the other one is at B. So it is made by AB, right? Great. What about if I follow angle Y? One leg is going to A, the other one is going to B. So it is also made by arc AB, right? Great. Now, these angles are equal provided, let's put the provision, they say that these angles that are in the same segment are equal. So here is the rule, is that they must be in the same segment. Okay? Yes, they are both at the circumference. Yes. They are made by the same arc. Yes. But another thing is they must be in the same segment. And whenever we hear the word segment, our mind rushes to chord. Yes, the chord is what we say makes segments. So where is this chord? We have to see it. Is this chord AB? Okay, we can have arc AB and we can have chord AB. Chord is a line that comes from one part to another without passing through the center, right? So yes, we can just have a straight line coming from A to B. That's the chord. So you can see that X and Y are all in the major segment, because the minor is this one, which I'm shading in blue, is a segment again. It is made by the chord, but it's a small one, so it's the minor. Both X and Y are in the major segment. They are made by the same arc, blah, blah. So they are definitely equal. Okay? Great. What the reason why I show you this is if you were to get something like this, I'm just putting an ugly diagram, and this is A and this is B. Okay? We can make it yes, we can make it something like this. Let me bring A and B down. Sorry. What if I do this? Okay. Let me draw a nice circle. Okay, so I'm going to bring, this is my point A, this is my point B. Let's say we now have a position like that. And then we have another one coming down here. Okay. Now, this angle in the top here, we can call it X. This one, we can call it Y. Now, X and Y, if we ask who is making the angle X, which arc? You can say arc AB, okay? Like that. And then, same applies to the angle, Y. It is being made by arc AB, okay? One leg going to A, one leg going to B. So they must be equal because they're both at the circumference. But where it fails is that Y, if we are to put the segments, we need to put a chord. To show the segments, we need to put a chord, right? And this chord would be from A to B, right? Let me put a pen again. Sorry. This chord would be from A to B, like this. That's your chord from A to B. And we can see that angle X is on top of the chord, which is in the major segment, the bigger one. And angle Y, this angle is in the minor segment. So they're in different segments, so that means it doesn't work. So they have to be in the same segment. Now, number 5, opposite angles in a cyclic quadrilateral are supplementary. Let's show. Cyclic quad is a quadrilateral, is a shape with 4 sides, right? And all the 4 corners would be sitting at the circumference. So 1, 2, 3, 4. All the 4 corners, all of them, all 4 of them should sit at the circumference. If one doesn't or 2, then it's out. All 4 of them. Okay? And now when it's like this, we have our cyclic quadrilateral. And opposite angles, if we call this X, then the opposite would be, if we go down, it would be this Y. They say X plus Y is equal to 180 degrees because they are supplementary. Supplementary means they add up to 180, okay? Add up to 180. So the opposite angles in a cyclic quad add up to 180. Don't forget that. Don't forget that. 2 more to go and we are done. 2 tangents drawn from the same point, not points, outside to the point of contact are equal. So if we draw two tangents from the same point, point P, we draw a tangent like this, and we draw another tangent like that. Now, these two tangents, if we make them end right at the point of contact, okay? Sorry. We want them to end right at the point of contact, which is right here. So this part is not there, and this thing is not there. They are ending right at the point of contact where they touch the circle. That's where they are ending. If they end there, then they will be equal. Okay? If they are coming from the same point outside P, and both of them are ending at the point of contact, then they are equal. Okay, these two tangents will be equal, and we show by putting this line. This line shows that these two tangents, these lines are equal. Okay? Now, number 7. The angle between the tangent and its chord, this is the nicest one, okay? Here's what I'm going to show you. Let me go ahead and show it to you without having to read the whole thing. The angle between a tangent and its chord. If we put a chord at the point of contact. So there is a chord, which is a line that comes from one side to another, but this one is going right to the point of contact. Here, we have a chord like that. Now, the angle between the chord and the tangent, this angle, okay, this angle is the same as the angle made by the chord. So the chord makes another angle here, which we will call Y. So that is what happens. We are saying that this angle, if I call it angle, if I call it X, let me call it X, let me give it a letter. We are saying X is equal to Y because the angle between the tangent, here is our tangent, okay, and the chord, here is a chord. You must be able to see it, even though it's part of a shape. Drawn to the point of contact. So the chord is going right to the point of contact. It's not a radius this time. It's a chord that's coming. Now that angle is equal to the angle made by the same chord in the other segment. So the angle that the same chord makes, this angle Y, is just the same as X. That is what you must know. And if you know these 7 theorems, then you should be able to do some questions. I'll give you one more thing which we might use in second theorem questions that comes a lot, and that is going to be the geometry of parallel lines, and you are done. Okay? Bravo, see you in the next video.